Hi everyone, welcome to the fundamental tutorial of DC Suite. This video will take you go through the process of arranging the patterns on Avatar to stitch and simulate. Multi-layer simulation and special situations will also be included in this video. There are two ways to import patterns into DC Suite. One is to import paper pattern images into the software. The related video of this method is linked on the right top. The other way to import patterns into DC Suite is to import DXF files. I will show you how we can organize the patterns after importing. In the Import Settings window, we can select Import as Complete AAMA or ASTM format, and to include seam allowance if there are. Click OK, and we can use the Select function to drag a rectangle to include all the patterns. Click Rotate in the 2D toolbar and right-click to enter 90 degree and press Enter. Use Translate function to drag the little gray rectangle to move the pattern to your intended position. If you want to delete the panel annotation from DXF files, select the panel and go to Property Editor. Under Attribute, we can find the panel annotation area and delete it. Right-click the mouse to drag a rectangle to zoom in, and we can see that there are many control points on the front neck. To reduce the control points, we can go to Line, Reduce Control Point, and select the line you want to reduce control point. The red points are the preview of remaining control points. We can right-click to change the numbers of remaining control points by moving the slider bar and press Enter. If you don't want to see control points, go to Show, Control Point, to disable the appearance of control points. To delete the unwanted interior lines on the panel, we can turn off the Enable Panel selection and drag a rectangle to include the lines you don't need. Press Shift to continually select the lines at one time and delete. I'm going to give you another example if the imported DXF file includes seam allowances. Generally, we don't need seam allowances in 3D garment making unless the patterns are for production. After importing, you may want to delete or adjust the seam allowances. We can go to Seam Allowance in 2D menu and select Define Seam Allowance. Left-click to the middle of the panel and click Yes to convert the seam allowances. Then you can right-click to enter the value of seam allowance you want to change. To delete the seam allowance, click Seam Allowance, delete Seam Allowance, and select a line or panel. Or you can drag a rectangle to include them all, and click Yes to convert and press Enter. Then all the seam allowances will be deleted. The final example of importing DXF files is when the file is not AAMA or ASTM format. You will see a warning saying that it can only be imported as draft, and we cannot choose from the Import As section. Only lines will be imported. In this case, we have to create panels from the imported lines. The lines may be divided into small parts because of the format, so we have to merge the lines to create panel. Go to Line, Merge Lines, and select the lines you want to merge by orders and press Enter. You can also left-click to drag a rectangle to include all the lines you want to merge, and press Shift to select more at one time, and press Enter. If the pattern is symmetrical, we can create half of the panel from the draft lines and convert to symmetric panel to save time. Delete the other half lines we don't use, and go to Line, Create Straight Line to create the center front line. Ensure the snap is turned on so we can snap the straight line from the center front neck to the hem. The difference between snap and split is that if there is only snap turned on, and we snap to a position on the line to create straight line, when we move the created line away, the original line is still the same. But if snap and split are turned on simultaneously, the line you snap to will also be split to two lines from the snapped point. After merging all the divided lines, we can start to create a panel. Use the Create Panel function in the drop-down menu of Panel. First, we can right-click to select whether we want to create interior line or point when creating the panel. Check the box if you want and left-click to select the control lines, and we can either select one by one or drag a rectangle to include all the lines and press Shift and then drag a rectangle to unselect the interior lines so that there will only be contour included in the selection. Then we can press Enter and proceed to selecting the interior lines and press Enter again. The panel will be created. You can always see the instruction of the function you are using from the left bottom of the window. Then we can go to Panel, Convert to Symmetric Panel, and select the panel, select the symmetric axis, and press Enter. After converted to symmetric panel, every adjustment on one side of the pattern will simultaneously happen on the other side. Now we have finished the process of importing and organizing the patterns. The next step is to arrange 2D patterns to 3D window for simulation. From previous session, we have talked about how to arrange patterns on cylinder by practicing with a t-shirt. Today, we are going to practice with this cycling top for some advanced arrangements. This is the patterns of a cycling top. We can see that some panels are across multiple parts of the body. For example, the top panel is across the front, back, and arm. The back panels are across back and arm. To set up patterns in advance, we can find the panel information in the Attribute tab of Property Editor. The Positioning tab and Positioning side can be set to locate the position on both 2D, Silhouette, and 3D avatar. Although it is very hard to define the tag of this shoulder panel, which across the front, back, and sleeve, we can still set a Positioning tab for it. I will set the Positioning tab Top for all the front-related panels, and the rest is also Top, but Positioning side is Back. After the Positioning tab and side is set, use Select function to select all the panels and click Arrange Panel on Avatar in the drop-down menu of Panel. Then you can see that the patterns are arranged on the 2D avatar silhouette according tabs I just set. We can click Fit to Avatar Front Silhouette to see more clearly, and I found that the position of the panels is a little low. The neck part is supposed to be placed near the neck, so we can just use Translate to move the patterns higher. Likewise, I would like to adjust the back. If you are satisfied with the arrangement in 2D window, select all the patterns and click Sync Panels to sync to 3D window. The patterns are roughly placed in the position due to the positioning tag and the placement onto the silhouette. To place the patterns around the avatar, we can open the wrap function and cancel the unwanted cylinder in the 3D layer setting. Then go to the cylinder selection mode to change the height and ratio if needed. After the adjustment is finished, we have to click back to the primitive selection mode so we can select the panels. For this cycling tab, only the front panels and the side panels can be placed properly on the cylinder. Then we have to manually arrange the back panels and the shoulder panel. First, we can use the translate function and rotate function to place the panel in the right direction. If we want to make sure the panels are in the right side, there is a function in Show, Vertex Normal in 3D window. The red face is the right side and the blue face is the wrong side. This is a way to tell whether the panels are placed in correct direction. Then we can enable the manual wrap in Attribute tab to adjust the ratio. Use Translate and Rotate again to alter to a more reasonable direction. After doing manual wrap, we can use the vertex selection mode to progress to arrange the most difficult part. In DC Suite, the panels are consist of triangular vertex, and we can use it to do manual manipulation in 3D environment. Vertex selection mode is in both 2D and 3D window. When we are in this mode, only vertex can be selected and we can do the manipulation by selecting the vertex. Usually, it is safer to select the vertex in 2D window because it is easily to select to other vertex you don't actually want when in 3D environment. For example, if I select the vertex from this angle, I cannot see the overlapped panels. I will accidentally select the vertex on the other side. Worth mentioned is that if no panel is selected in primitive selection mode and we just change to the vertex selection mode, all the panels will be in vertex, and it will be very easily to select to the wrong vertex. If you select the vertex from front, some vertex from the back will also be selected in certain angle or viewpoint. To avoid this situation, it is recommended to select the panel before go into the vertex selection mode. So if I select the shoulder panel in primitive selection mode and go to the vertex selection mode, I can see only the panel I selected is in vertex. Next step is to select the vertex in 2D window, then rotate and translate in 3D window. For the back, I will also do the same. We can also use the method to jack the vertex of the back panel into the underarm area where it should be placed when progress to stitching. This will need more accurate manipulation by using translate and rotate. If you are not certain about the direction of panel after rotating, you can always check the vertex normal to make sure the red face is on the outside. After arranging all the panels to the intended position, we can proceed to stitching and simulation. If we want to stitch the patterns together, we have to use Create Seam function in 2D or 3D menu. There are two kinds of seams in DC Suite, merging seam and attaching seam. Generally, merging seam can be used in most of the garment constructions, but some garment details will need attaching seam to support. For this cycling top, I will use merging seam to stitch the panels together, and attaching seam will be demonstrated in the next practice file. We can use Create Merging Line Seam in the drop-down menu Seam to stitch two lines together. You can click the line one by one and press Enter. Or you can right-click to drag a rectangle to include these two lines and press Enter to finalize. Then the seam will be shown in gray area in 3D window. If the Enable Seam selection is turned on, we can select the seam in 3D window and it will become orange. If you want to change the type of the seam, you can go to the Seam Information under Attribute tab. If you want to see the seam in 2D window, click Show Merging Seam in 2D menu and you can see the seams that have been created. If you want to stitch more than one line at one time, for example, to stitch this horizontal design line, we can select the drop-down menu, Seam, Create Merging Multi-Seam. The reminder beside the cursor will suggest us to select the first sequence of lines for multi-seam, and I will select the two lines on the top in order and press Enter. Then, to select the second sequence of lines from the same direction too. So I will select these three lines from the front panels one by one. As you can see, the program will calculate the proportion of the division from the number of lines you select to stitch with the other side. The preview shows that the lines are properly divided, so I can press Enter to finalize it. Now, the seams are created and the lines are well divided. Let us continually create merging line seam to stitch the rest part of the garment, and we can progress to simulation. After all the seams are created, we can check if there are penetration through the seam and avatar or panel and avatar, and use translate function to adjust to a find position. Then we can click static play to simulate in this A pose. If there are some parts not fitting so well, select all the panels and right-click Stiffen Panel to simulate again. The toggled part on the garment will be stretched, and we can right-click to unstiffen the panel to static play again. If we enable the catch and click Dynamic Play, the garment will be calculated with the avatar animation through the simulation. And every frame on this time axis will be saved. If we back to the first frame and click Catch Play, the animation process we just saved can be played again. If we move the frame to the last frame and clear Catch, all the simulation process will be deleted and the garment will stay in the position of last frame. Now I want to change the pose from Avatar Editor to long jump. The preset pose of long jump is different from my garment, but I can drag the vertex of the sleeves and use static play to simulate again. If the garment is not dressed well, we can use the Stiffen Panel function again to stretch the tangled part of the garment. And unstiffen the panel to simulate again. The garment will fit better after doing this action. Then click Dynamic Play and enable Catch to play animation. If you want to export the animation, we can set the background in Environment Background setting to Gradient or your own image. Rotate to your preferred angle and click Export Catch to Video. You can set the start and end frame in the export setting and to decide whether you want to export with background or shadow. These are the videos I exported. After we complete the simulation of cycling top, next, I am going to use another example to show you how we can use different seams on different types of garments to simulate. In the 3D window, we can see that the panels are arranged and stitched together in advance. The overlapping area like front fly and belt will be using attaching seam to simulate because they should not be completely merged together. Also, the binding on the top is suitable for using attaching seam so that they can be attached on the main body. Before progressing to simulation, we can set thickness for the top and trousers. There is a checkbox of bidirectional thickness. This is default as check. When it is checked, it means that the thickness will increase from both sides of surface. For example, if we find thickness under the attribute tab, we can enter the value in centimeters. If the thickness is 1 centimeter, there will be 0.5 centimeters on each side of the panel surface. I'm going to set the thickness of top and bottom 0.1. Then click Static Play. We can see some area of the binding are inside the main body. To solve the problem, there are two things we have to check. First is the characteristic of attaching seam. If we are stitching in attaching seam, we can decide the distance between two panels by changing the rest length. We can cancel the showing of merging seam and cancel enable point, line, panel selection so that we can only select attaching seam. By dragging a rectangle to include all the attaching seam, we can change the rest length in attaching parameters in Attribute tab. The way to calculate the rest length is to include half of the thickness of the two panels. Like I have mentioned before, the thickness is equal on two sides of the surface, so each side contains half of the thickness. The rest length of the attaching seam must be equal to or bigger than the half thickness of binding plus half thickness of main body, which brings to 0.1 centimeters. So the panels will not penetrate after simulation. In this case, I will set the rest length 0.1. Another thing we can do for avoiding penetration is to set a sublayer of bindings in the collision area under Attribute tab. Sublayer setting is for the outside and inside relationship in a single 3D layer. Any numbers bigger than the inside layer would be fine. In this case, because the sublayer of main body is default 0, so I can set the bindings as 1. And let us simulate again. Down to the trousers, I found that the front belt has some problem. The left belt is supposed to be inside the right belt. To solve the problem, I can set the sublayer of right side to 1. Then to change to vertex selection mode in both 2D and 3D window. I can drag the vertex part I want to move in 2D window. The vertex will become yellow in 3D window too. Then I can use Translate to move the right side of the belt outside the left one in 3D window. Back to the primitive selection mode, and then simulate again. We can see that the issue is solved. These are the tips for stitching and simulation. In next part, we will talk about multi-layer simulation. Before we start multi-layer simulation, let's look into some settings of 3D layer. In Layer Browser, we can find 3D layer setting. In the Simulation Parameters tab, we can set the simulation quality. Usually it is set to low because higher quality needs more time. You can change to your preference. Gravity can be adjusted here when making special garments or effects. In simulations per frame, bigger numbers represent more calculations and the result will be more delicate. Accuracy is also related to simulation results. Bigger numbers will take more time but come out better results. In the collision handling section, we can adjust the collision checking times in max collision check iteration. Self-collision is the collision between the panels in one 3D layer and is usually checked. The resolve tanglement is when your garment is easily to toggle together. You can check this box before simulate. This part is about collision between a 3D layer and other objects. If the collision to avatar and floor are not checked, the garment cannot detect these two objects and will fall down from the avatar and under the floor. We will set the offset to avatar depends on the situation and the 3D layer numbers to prevent from penetration to avatar or other layers. Another thing related to the simulation result is intervertex distance. We can find the intervertex distance setting in the triangulation under Attribute tab. It is the distance between the vertex. The larger numbers represent far distance from each vertex, and the simulation will not be so delicate. If I change the 2D window mode to vertex selection mode and change IVD of the skirt to 2, you can see that the triangulation in 2D window becomes larger. The shearing effect on my skirt becomes plain and rough. If I change to 0.5 and simulate, the simulation becomes delicate but takes more time. Generally, we will set the intervertex distance between 0.8 to 1. But if there are some special situations requires, you can always adjust the setting to gain better results. Now, to simulate two garments together, we can simulate one garment in one layer. So there will be two layers in 3D garment layer section. There are three little icons in front of the layer name for us to utilize. The first one is to control the show of this layer. The second is to control the simulation to this layer. If it is turned off, this layer will not be included in the calculation of simulation. The third one is to control the collision of this layer. These three buttons are independent and will not be influenced by each other. On the right side, there are layer colors that can be changed. You can change the color and go to Show, Panel Mode, 3D Layer Color. Then the skirt will be shown in the layer color you choose. This is for us to tell the different layers more easily when doing multi-layer simulation. If I am satisfied with the simulation of skirt, I can switch off the simulation button of skirt and remain collision and show, so that the skirt can be detected by the top to do collision, but the skirt itself will not be influenced when simulating the top. Then I can switch on the show, simulation and collision of the top. There are two things we can check before doing the multi-layer simulation. First is to check the offset to avatar of these two layers. Generally, I will set offset to avatar of the inner layer smaller, like 0.1 cm, and outer layer for 0.4 cm, so that there will be distance between these two layers. Second, we have to click this icon on the bottom for interlayer collision handling adjustment to check the collision between layers. Usually, we don't recommend to change the value bigger because sometimes it may cause the penetration to avatar. So let's start the simulation. There is a little arrow in the left bottom of 3D layer. If the shape of the garment is strange, we can use this button to make the multi-layer simulation better. This is to control whether the outer garment to follow the inner garment or the opposite. If I want to tuck the top inside the skirt, I have to exchange the position of top and skirt in 3D garment layers. The inner layer will be on the top and the outer layer on the bottom. Then to change the inner layer offset to avatar to 0.1 and outer layer offset to avatar to 0.4 and simulate. Then the top will be tucked in the skirt. If the shape near the waist is strange, click the little arrow again to adjust the fit. We can see that there are still some extra fabrics on the back. We can stiffen the top to simulate and unstiffen again so the top will be well tucked in the skirt. This is our final result of multi-layer simulation. There are some constraint functions related to 3D simulation that will be used in certain situations. In the final part of today's video, we are going to practice with a dress that has wider neck width. For this kind of garments, which are easily to fall from the shoulder, we have to do some extra settings to stabilize the simulation process. First, we can simulate this dress in static play. And the garment is dressed well. But when we click dynamic play to do the catwalk, the dress will fall from one shoulder. After clicking pause to stop the dynamic simulation, we can use the static play to simulate again in this pose. Then go to Constraint, Vertex Drag, so we can gently drag the strap back to the shoulder. Try not to drag too quickly while using this function, or the garment will be pulled dramatically. After the garment is back to a satisfied position, we can use a function in constraint to make sure the neckline is attached to the body while doing simulation. First, click the vertex selection mode and select a vertex on the front neck and press Shift to select more at one time. Left-click to select line vertices, and you can see the vertex in front neckline is all selected. Then we can go to Constraint in the menu to select Create Attach Constraint. The selected line vertices will become blue ones, and the front neckline will be attached on the avatar in the current position, no matter it is in static play or dynamic play. The neckline will attach to the according position. We can do the same for the back neckline. Back to the primitive selection mode and play static play to simulate. Let's go back to the first frame and click Dynamic Play. This time, the garment will not fall from the shoulder. When clicking to Vertex Selection mode, the blue vertex shows the attach constraint I have just created. Another function similar to attach constraint is the fix constraint. It is also in the menu of constraint, and the vertex assigned to fix constraint will be fixed in this environment. If I drag the vertex using Translate and create fix constraint, after clicking Static Play, we can see that the simulation of the jet is influenced by fixed constraint in an unnatural way. This function can be used in the situation when you need to simulate panels without Avatar 2. These are the related functions to constraint in DC Suite. We can utilize them while making different kinds of garments. I hope you enjoyed today's video. You can go through the contents by practicing with the files in below link. Don't forget to subscribe to our YouTube channel and turn on the bell to get notifications. See you in the next video.